Modern software is complex. We find complexity all around any code base, but not all sources of complexity are equal. One source is expressions. Complex expressions hurt code readability. They hinder our ability to think about the code we read. In this video, I will show you one typical class which is all about expressions. I will then apply a special coding technique that will move that complexity out, restoring code readability back again. Stay with me. I will now teach you how you can make even the most complex expressions in your code beautiful and easy to read. This is the class modeling money in some e-commerce application. As I said, it is all about expressions. There are so many expressions here, as you can see. Look, for example, how addition of two instances of money is implemented. For a pattern matching expression, which has a couple of sub-expressions inside of it. This sub-expression is comparing currencies between two instances of money, because only the money with the same currency can be added together. On a positive outcome, there's another expression, sub-expression, where a new money instance is created. Otherwise, on a negative outcome, there is a throw exception sub-expression. All this intrinsic complexity is hurting readability. What is this expression doing and how? It's not so easy to understand. And so to get straight to the point, in this video I will advocate introduction of new methods, private methods, even static methods, that will take over the burden of parts of a large expression. Look here, this method is clearly communicating a failure when currencies are mismatched. There are a couple of technical details that we must get right. The method is returning money because it will be used as part of a larger expression which maps to money, so in order to make that expression compile, we need to return the same type from this method, unfortunately, because this method will just throw, it will never return anything. And also this method is receiving a parameter which will make it useful in multiple calling places. When it comes to implementing this method, it will be a no-brainer. Just throw the exception and make sure to format the exception message appropriately to include the operation that has caused the failure. Now, if you look at this static private method, this is the utility method, its sole duty is to deal with a lower level detail, a level that is lower than the level at which the expression above is thinking. We are pulling out one detail so that we can make the expression above more readable by focusing on its own primary duty. Look here. Instead of throwing the exception itself, it will say that it must fail with currency mismatch on the add operation. Doesn't this look better already? And it is only the beginning. This same utility method, we can use it in money subtraction as well, making even that expression a bit easier to read. And here in the comparison operation too. But unfortunately, this has caused the compile time error. This is where things become messy because of the C# syntax. The whole expression where I have planted this call is supposed to return an integer. But the fail with currency mismatch is returning money. There is a type mismatch here. In order to get out of this trouble, we must do something. Either implement another similar method that would return integer, or, for example, make this method generic, so that we can specify the declared return type, because the method, again, never returns anything, but we only need a declared return type to make it compile. So there will be an integer return type, and above, in both places where I called it, it would be money. The method would formally be generic. It would pretend as if it returns some generic type t, but again, it will never return anything. I don't like this part of my demo. That's what we must do to satisfy the C# compiler. However, the best part is yet to come. This entire utility method, why is it here? I will cut it from this place, move at the very bottom of this large class and place it there. Because I believe the bottom of the class is the place which I will never open to read. So you can move all these utility methods that are implementing sub-expressions back at the bottom of the class, hoping that you will never see them again there. If I get back to the places where I used this utility, read the expressions now. They are truly a tad easier to read with this call instead of the throw expression. I will now replace other sub-expressions too, and you will see that half of this code will be gone in a couple of minutes. Before that, let me remind you, if you liked this video so far, please press the like button. That will bring more people like you to my channel. Thank you. Let's move on. I want to create similar utility methods for other sub-expressions that I saw above. This one will throw when there is insufficient money in subtraction. Again, a nasty throw expression, very long one. I don't want to see it anywhere above. But some other utilities will be more engaged and more related to this instance of the money class. A Boolean test that compares money object, this object, to another money object. It returns true if both instances have the same currency. This is instance level method because it takes state of this instance and it returns Boolean. We will use this method in Boolean tests above. Another similar Boolean condition which tests whether there is sufficient amount in this instance to support subtracting another instance. Now look, it depends on testing the currency, so only if currencies match and the amount is sufficient will this method return true. That is exactly what we needed above in subtraction. I will now use these methods and you will see that they will simplify all the methods above. And if you want to download the source code, it is available at Patreon. So visit my Patreon page and find source code there if you want to read it. Here we are. We want to fix these unreadable methods. Verifying currencies. Just ask for the service. Currency as other. And this expression to the right, there are with expressions. This class is a record and records support with expressions in C#. So I can use a with expression to say that I only want this instance with the changed amount. Subtraction will sustain similar changes. This first expression is about comparing amounts, so let's ask it to compare no less than the other. If so, then I will turn the right-hand side to the form of a with expression again. The last remaining test here is to verify the currency. This condition means that there is no sufficient money, obviously, so we call the method fail with insufficient funds. Look here, I haven't reordered anything. I have left all the logic intact. I didn't deal with the logic. I have just given names to each sub-expression so that the existing large expression now reads more fluently. It reads more like a requirement from which it was implemented. I believe you will agree with me that this form of my code, while doing the same thing as before, is much easier to read than it was at the beginning. So that was it. A very simple technique. It costs you very little. Just give names to expressions and put calls in places of sub-expressions in a large expression, and that will make your code more readable than it was. I hope you enjoyed this video. Don't forget to like it. Don't forget to visit me at Patreon if you want to download the source code. and see you in the next episode.